So this chain rule differentiation really just takes practice doing, and it takes practice identifying the outside and inside, and just practice how we apply it. But once we apply it, we should develop some fluency in it. So in this case here, when I differentiate this, I'm going to have f prime of x, okay, and that's going to be equal to, and I'm going to differentiate the outside. Okay, so I just going to look at the blue part of this function. So that 3 is a constant. The power is going to be negative 1/2. So I'm going to decrease the power by 1. So I get negative 3 over 2. And the inside part stays the same. I've now differentiated. Oops, sorry. Forgot to multiply the power there. So it's going to be negative 1/2 times 3. That's my power. I'm going to reduce the power by 1, so I get negative 3 over 2. And then I'm going to apply the chain rule. So once I've differentiated outside, I work inside, and I get 4x minus 2. Make sure you group that in brackets. And there is my chain rule derivative. Now, it might be worthwhile to simplify this, so I'm going to end up with negative 3 4x minus 2, and in the denominator I have 2, and then this is 2x squared minus 2x to the power 3 over 2. So there is my derivative, and I have my outside derivative in blue times my inside derivative in red. Okay, and again, if I want to apply my notation to this, I can say that f of u is equal to 3 over root u, and so the blue part represents the derivative of that, and then the u part is going to be the inside function 2x squared minus 2x, and that chain part represents the adding of the derivative of that inside function. Okay, so again, I'm just going to split this off because although it is good to know the notation here, really we want to differentiate with some fluency, and we're going to do it by identifying inside and outside functions. So here we'll do the same thing. I'm going to differentiate outside to inside, so f prime of x. I'm going to differentiate the outside. Well, it stays the same. It's an e function. Okay, so the red function represents my embedded function. I differentiate the outside e function, so it all stays the same. Then I apply the chain rule, and I differentiate the inside part. So it's 2x plus 3. Make sure we group that into brackets, and there's our derivative. Okay. Again, if we want to show it in components, the f of u is e to the u. Okay, and that first part of the derivative here, so this part here is going to show up here. That's the derivative. And then the inside derivative is going to be the derivative of this u function, which is x squared plus 3x. Okay, let me just clear that up. So x squared plus 3x. So then the derivative of that part is showing up. Okay, so the derivative of this part just shows up down here.